Hello, this is another video on smart contract security, and this time I would like to talk about block gas issues, in particular what happens when you reach the block gas limit with your transactions. And this is quite a common vulnerability that I've come across quite a few times in my security audits, and it's sort of an issue particular to smart contracts, which is not that obvious, and it's easy to fall into this trap. So let's have a look. First of all, what is the block gas limit? Well, as you probably know, in Ethereum and most other smart contract platforms, transactions have a cost associated with them. In Ethereum, that is called gas. And basically, each operation that is processed by the virtual machine has a specific cost expressed in gas, and gas is paid for with Ether through the gas price. But basically, a very simple transaction, just transferring some Ether, requires 21,000 gas. More complex transactions require more. Basically, it depends which opcodes you execute and the storage requirements of your code. But anyway, transactions are added into blocks, and blocks have an upper limit of the gas they can include. So the gas of all the transactions added up cannot exceed currently 8 million gas. And that basically means if your transactions get too large, they won't fit into a block anymore, meaning they will never get executed, which is of course a problem. It's sort of a homemade denial of service scenario where your own transaction cannot get accepted by the blockchain. So let's look at a piece of code where this is happening. This is a very typical example. Basically, the Ether is meant to be paid out to a number of users, and these payouts are stored in an array, a variable size array that can grow over time. And then there's a payout function that just iterates over this array and makes an Ether transfer here. Now this seems fairly straightforward, and at first sight there might not be any problem with that. But given that this array can grow in size, it can actually become too large, meaning that this payout here would consume too much gas and the block gas limit would be exceeded. And this basically would mean that this transaction here can never succeed. It would always fail. It would never be included in a block. And this is obviously a problem because it means that in this case here, unless there's some other way of getting this Ether out of the smart contract, all the funds are stuck. And this does happen quite often. And it usually happens when you iterate over arrays that can grow in size. So that's something to watch out for, which brings us to best practices. So obviously, not just for this, but in general, you have to be aware of the gas requirements of your code. Think about how much gas a function might consume. And in general, you should avoid iterating over variable-sized arrays, because if they do grow too big, then the code is stuck. If it is necessary to iterate over a number of items or an array, make sure that you do it in reasonable sized steps. For example, process 100 payouts at a time, and then you just have to perform several transactions. But in general, whenever payments are involved, it's best to stick to the pull over push payment pattern. And we've talked about this before. Basically, it means that you don't push payouts out to users. You don't just make Ether transfers within the context of some other code. You just mark it as withdrawable, and then that user can invoke a very simple transaction, a withdrawal function, to take this to withdraw these funds. And that's much safer for a number of reasons. But one of the reasons is that you avoid iterating over arrays of payouts and run into this problem. Anyway, that was a fairly simple explanation of a fairly simple vulnerability, but it's not an obvious one. It's easy to get this wrong and have some code that works in testing, but then when the arrays grows, just stops working in production. And that's obviously a huge problem. So anyway, as always, get your smart contracts audited, and I'll be back with another video soon.